Ever look up at the night sky and wonder if there's more out there? Like, way more.
More than just a few extra stars, you mean?
Oh, yeah. I'm talking about the possibility of entire other universes existing alongside our own. A multiverse. It's a concept that's captivated scientists, philosophers, and science fiction fans for generations.
And today we're going to separate fact from fiction and dive deep into the science behind the multiverse theory.
Exactly. We're going to explore some seriously mind-bending concepts based on cutting-edge research, scientific papers, a Cornell University study from just last year, and even an essay that gravels with the question of whether the multiverse is truly science or still in the realm of myth.
Should be interesting to unpack all that.
For sure. I'm especially intrigued by that Cornell study using something called ferromagnetic fluids. Who knew that magnetized liquids could give us clues about the existence of a multiverse?
Yeah, that one caught my eye too. But let's not get ahead of ourselves. Before we dive into the evidence, let's start with the basics. What exactly are we talking about when we say multiverse?
Great point. It's easy to get lost in the science fiction hype. So, what is the multiverse from a scientific perspective?
Well, at its core, the multiverse is the idea that our universe, the one we can observe with all its galaxies and stars and planets, is just one of many, perhaps an infinite number of universes.
Whoa, infinite. So basically, there could be a universe for anything you can possibly imagine.
Pretty much, yeah. And these other universes might be radically different from our own. They could have different physical laws, different fundamental constants, even a different number of dimensions.
Okay, so different dimensions, different laws of physics. It sounds pretty far out there. Where does this idea even come from?
You'd be surprised to learn that the term multiverse actually predates a lot of modern physics. As that essay you sent pointed out, it was coined by the philosopher William James way back in the late 19th century.
Oh, wow. So it's not just a recent idea.
Not at all. But the modern scientific interest really focuses on whether this idea arises from solid physics, not just philosophical musing. And it turns out it does. The concept of the multiverse emerges from several key areas of modern physics.
So where do these scientific theories intersect with this, let's face it, pretty wild idea of multiple universes?
One of the primary origins of the multiverse idea lies in quantum mechanics, specifically in something called the many worlds interpretation, or MWI.
MWI, okay. What's that all about?
The MWI, which goes back to the work of Hugh Everett III in the 1950s, suggests that every time a quantum event occurs, the universe branches. Instead of just choosing one outcome, it splits into multiple parallel universes, each representing a different outcome of that event.
Hold on, let me see if I understand this correctly. Say we have a particle that has a 50-50 chance of spinning up or down. In our universe, it spins up. But the MWI says that another universe splits off where that same particle spins down.
Exactly. And this splitting happens constantly with every single quantum interaction throughout the universe. Imagine it. Every choice, every possibility, every random event splitting the universe into countless parallel realities.
Okay, now that is mind-blowing. So, in some alternate universe, I'm having pizza for breakfast right now.
Maybe. And in another, you might be the president. The possibilities are literally endless.
I think I need a minute to process that. Infinite versions of myself.
It takes some getting used to, that's for sure. But the MWI isn't the only piece of the puzzle. Another major area that leads us to the multiverse is string theory, specifically what's known as brain cosmology.
String theory. I've heard of that. Something about tiny vibrating strings making up the universe.
That's the one. Now, string theory also predicts the existence of extraspatial dimensions beyond the 3 we experience, up to 10 or 11 dimensions in total.
10 or 11 dimensions. That's even more mind-boggling than infinite universes.
I know, right? So, brain cosmology takes this idea of extra dimensions and suggests that our universe exists on a 3-dimensional membrane, or brain, within this higher dimensional space.
So, like, our universe is just a sheet floating in a larger space with more dimensions. And what's on the other sheets?
Well, that's the key point. According to brain cosmology, other brains could also exist within this higher dimensional space, each potentially representing another parallel universe.
Like a whole stack of cosmic pancakes.
It's a helpful analogy, and the theory even suggests that these brains can interact, they can collide, and these collisions could be responsible for events like our own Big Bang.
Wow, cosmic fender benders creating universes. It's amazing how these theories connect. Okay, so we've got quantum mechanics with its branching realities and string theory with its brains and extra dimensions. What's the third major contributor to the multiverse idea?
The third piece of the puzzle comes from the theory of cosmic inflation, specifically something called eternal inflation. Eternal inflation, that sounds pretty intense. Fill me in. Well, the standard inflationary theory explains the rapid expansion of the early universe, right after the Big Bang. Eternal inflation takes this a step further and proposes that this inflationary process didn't stop everywhere at the same time. It's still happening in certain regions of space, even now.
So parts of space are still inflating like crazy even though our universe is settled down.
Exactly. And as these regions continue to inflate, they can give birth to new bubble universes, each with its own unique set of physical laws and constants. Our observable universe might just be one such bubble in a much larger, eternally inflating cosmos.
So it's like a cosmic bubble bath with universes constantly popping into existence. Okay, I think I'm starting to grasp the theoretical framework here. But if all these universes exist, how could we possibly ever know for sure?
That's the biggest challenge with the multiverse theory. The very nature of these other universes and the way they're thought to be separated from us makes direct observations seemingly impossible.
Right, if we're in different dimensions or expanding faster than light, we
Mhm.
can't just point a telescope at them. So how do scientists even begin to look for evidence?
Scientists have to get creative and look for indirect evidence, subtle hints that point towards the existence of a larger reality beyond our own. It's like trying to study a distant storm by looking for ripples in a pond.
Okay, that's a good analogy. So what kind of ripples are scientists looking for in the cosmic pond to prove the multiverse?
One key area of investigation is the cosmic microwave background, or CMB. Think of it as the afterglow of the Big Bang, a faint radiation that fills the entire universe.
The CMB, right, like a baby picture of the universe. I remember that.
Exactly. Now, a Durham University study back in 2017 found some really interesting patterns in the CMB, specifically these large circular regions that are significantly colder than their surroundings. They call them cold spots.
Cold spots in the afterglow of the Big Bang. That definitely sounds weird. What could cause that?
Well, one hypothesis, and this is where the multiverse comes in, is that these cold spots might be imprints left by the gravitational pull of other universes on our own, way back during the Big Bang. Imagine these universes brushing up against each other, their gravity tugging at our infant universe and leaving these temperature fluctuations as a kind of cosmic scar.
So like a gravitational bruise from another universe? That's wild.
It is a compelling idea, but as always in science, there are alternative explanations.
What are some of those alternative explanations?
Well, the most widely accepted explanation among scientists is that these cold spots are caused by vast, ancient superclusters of galaxies whose gravity has distorted the CMB radiation.
So those cold spots might not be evidence of a multiverse after all. Bummer.
It's still an open question, and the CME continues to be a source of intense research.
Okay, but what about that Cornell study with the ferromagnetic fluids? That seemed like pretty strong evidence for the multiverse.
Yeah, that study was really ingenious. So ferromagnetic fluids are basically liquids that become strongly magnetized in the presence of a magnetic field. What the Cornell researchers did was study how these fluids transition from a metastable state, like a pencil balanced on its tip, to a more stable ground state, like the pencil lying flat.
Okay, and what does that have to do with the multiverse?
Get this. The way these ferromagnetic fluids transition between states actually mirrors the theoretical predictions for how the expansion field, the force that drove the early universe's inflation, might decay, leading to the formation of bubble universes.
So they're saying that by studying these fluids, we can learn something about how universes are born.
Exactly. The researchers themselves concluded that their findings are broadly consistent with the idea that the multiverse, as described by eternal inflation, might actually be real. They're not saying it's a definitive proof, but it's a pretty compelling piece of evidence.
That's incredible. Using something as ordinary as fluids in a lab to study the creation of universes, science never ceases to amaze me.
The researchers do point out that their experiment was linear and one-dimensional, and to get even more convincing evidence, they need to explore these transitions in 2 and 3 dimensions, which they are actively working on now.
It just makes you wonder what other secrets are hidden in plain sight, waiting to be uncovered. The article also mentioned something about Bose-Einstein condensates. What are those and how do they connect to the multiverse?
Bose-Einstein condensates, or BECs, are another really interesting area of research. Basically, a BEC is a state of matter where atoms are cooled to extremely low temperatures, causing them to all occupy the same quantum state and behave as one single quantum entity.
So they're all doing the same thing in perfect unison.
Pretty much, yeah. And what's fascinating is that researchers have observed microscopic vacuum bubbles spontaneously forming within these BECs.
Tiny bubbles in a supercooled atomic soup. Sounds like a science fiction recipe.
Well, here's the connection to the multiverse. These tiny vacuum bubbles forming in a lab might share fundamental similarities with the way much larger cosmic bubbles or universes could have formed during the process of eternal inflation.
So by studying these microscopic bubbles, we could gain insights into the birth of entire universes.
Exactly. It's like looking at a miniature model of the early universe. In fact, the scienceinfo.net article mentions ongoing experiments using potassium atoms to study this phenomenon more closely, and they're expecting some exciting results next year.
I'll be keeping an eye out for that. It's amazing how studying something so small can give us clues about something so unimaginably vast. It really highlights the interconnectedness of physics. Now, one more concept I wanted to touch on is anthropic reasoning. How does that factor into the whole multiverse discussion?
Anthropic reasoning is all about the apparent fine-tuning of our universe. You see, the fundamental constants of physics, things like the strength of gravity or the charge of an electron, seem to be incredibly finely tuned to allow for the existence of life as we know it.
It's like the universe was designed specifically for us, which seems a bit too convenient, don't you think?
Right, and that's where the multiverse comes in. Anthropic reasoning suggests that if there are a vast number of universes, each with its own unique set of physical constants, then it's not so surprising that we find ourselves in a universe that happens to have the right conditions for life.
So it's a matter of probability. In an infinite multiverse, there's bound to be a universe where things are just right for us to exist.
Exactly. It's like winning the cosmic lottery. Of course, we could only ever find ourselves in a universe that supports life, otherwise we wouldn't be here to observe it.
It's a bit of a mind-bending thought, but it makes a certain kind of sense.
It does, but anthropic reasoning also has its critics. Some argue that it's not truly scientific because it's difficult to test directly.
I can see that.
Yeah.
It's hard to prove something when you're relying on the fact that we exist as the evidence.
Right. But it's still a fascinating concept that's worth considering.
Okay, so we've talked about a lot of compelling evidence for the multiverse, but let's be honest, it's all still pretty speculative.
Yeah, there are definitely challenges to the idea.
I mean, the most obvious one is that we can't directly observe these other universes.
That's a major hurdle. As we discussed, the very mechanisms that might give rise to other universes, like faster-than-light expansion, also seem to isolate them from us.
So it all comes down to indirect evidence, which can be open to interpretation.
Right. And this raises the issue of falsifiability. How can we truly consider something a scientific theory if we can't, even in principle, design an experiment to disprove it?
It's a valid point. If we can never see or interact with these other universes, how can we ever be sure they're really there?
That's a question that scientists and philosophers are still grappling with. Some argue that certain models of the multiverse, particularly those that posit an infinite number of universes with every possible variation, are more in the realm of metaphysics than science.
It's like saying anything is possible because there's a universe for every possibility.
Exactly. But it's important to remember that science is a process of discovery, and what might seem untestable today could become testable in the future with new technologies and theoretical breakthroughs.
It reminds me of the long road to confirming the existence of gravitational waves. It took decades of research and technological development before we finally had the tools to detect them.
Exactly. So it's possible that future research might reveal more robust evidence for the multiverse or even entirely new ways to test these ideas.
I hope so. It would be amazing to confirm the existence of other universes in our lifetime. The essay also mentioned some of the philosophical implications of the multiverse.
The philosophical questions raised by the multiverse are profound. If there are countless other versions of ourselves out there, living out different lives in parallel universes, what does that mean for our sense of self and the significance of our choices?
It's a lot to wrap your head around. It challenges everything we thought we knew about reality.
And remember, we also talked about how the majority of scientists currently favor more conventional astrophysical explanations for things like the CMB cold spots. So while the multiverse is a captivating concept, it's important to keep in mind that it's still an active area of research and debate.
It's definitely not settled science yet, but it's a thrilling area of exploration. It's fascinating to think that the idea of multiple worlds isn't just a modern concept.
Oh, yeah. Like you mentioned, the idea of multiple worlds goes back a long way. Ancient Greek atomists like Leucippus and Democritus were already speculating about an infinite number of worlds arising from the random combinations of atoms in the void.
They didn't have the scientific tools we have today, but it's amazing how their intuition led them to consider such a profound idea.
It is. And then, of course, you have figures like Giordano Bruno during the Renaissance, who was persecuted for his belief in an infinite universe with countless suns and worlds.
And even Edgar Allan Poe, in his prose poem Eureka, wrote about the possibility of a succession of universes.
So, you see, the human imagination has been grappling with the idea of multiple worlds for centuries. What sets modern science apart is that we're now trying to tackle this question with the rigorous tools of physics and cosmology.
We're moving from philosophical speculation to scientific inquiry.
Exactly. We're developing testable theories, even if the tests are indirect, and we're grounding our ideas in mathematical frameworks.
Of course, we can't forget the role of popular culture in spreading the idea of the multiverse.
Oh, absolutely. Movies and books have taken this idea and run wild with it. From superheroes hopping between dimensions to more philosophical explorations of parallel lives, the multiverse has become a staple of science fiction and fantasy.
It's definitely captured the public's imagination.
But it's important to remember that these popular depictions often oversimplify the science, making inter-universal travel seem commonplace and glossing over the complex philosophical questions.
So while it's great that these stories spark curiosity and get people thinking, it's important to separate the science fiction from the actual science. So where does that leave us? Is the multiverse pure fantasy? Or is it something that science might one day confirm?
Well, I think it's safe to say that the multiverse is a compelling concept that emerges naturally from some of our most well-established scientific theories. The fact that quantum mechanics, cosmic inflation, and string theory all point toward the possibility of multiple universes is definitely significant.
So it's more than just a wild idea.
Exactly. But as we've discussed, definitive proof remains elusive. We have these tantalizing pieces of indirect evidence like the CMB cold spots and the behavior of ferromagnetic fluids, but they're still open to interpretation.
So the jury's still out, but the investigation is ongoing.
And that's the beauty of science. It's a process of ongoing discovery, and who knows what the future holds.
Maybe one day we'll have definitive proof of the multiverse, or maybe we'll find a completely new theory that changes our understanding of reality altogether.
Either way, it's an incredibly exciting time to be exploring these fundamental questions about the nature of the universe, or should I say, universes.
I'll leave our listeners with this thought. If the multiverse is real, what does that mean for our understanding of ourselves and our place in the grand scheme of things? It's a question that could fundamentally change our perspective on reality.
That's a question worth pondering. Thanks for taking this deep dive with us today.
Absolutely. Until next time, keep looking up and wondering.